So, most of the work related to data churning is far more easier with SQL, because you must have seen by now, if you have been in industry for some time, that SQL solves a lot of problems. For most of the work, programming and coding is not really possible, and because it's too much time consuming and it requires different kind of skill. Therefore, MapReduce is generally not the solution unless you need to do a lot of custom work. If you have to do a lot of custom work, which is not really possible using Hive, then you generally either go with extending Hive or go with MapReduce. Otherwise, you either go with Hive or Pig. The question with the Hive and Pig we'll discuss in a while, then when to use Hive and when to use Pig. Okay. So Hadoop is great, but how do you move existing data relations and SQL infrastructure? The whole IT industry across the globe works on databases. Okay, so probably every IT professional who is into in one way or the other related to data works on SQL. So and lot of data of the world is actually inside databases, so it's not really possible to move that existing infrastructure to something like Pig or something like MapReduce, right? Therefore SQL has to be there. All right. That's where Hive come in. Hive is not a database. Hive is more like Pig. Hive is more like Pig in the sense that you write your code, you write your SQL queries to churn data, and that SQL query under the hood gets converted into MapReduce. All right. Next is, so the most value proposition of Hive is it's mostly suited for data warehouses. It is great for analyzing relatively static data. Okay, when you don't require fast response, and it makes it easier to port existing projects. It provides a good SQL dialect called HiveQL, and it maintains the meta store for metadata. We'll come back to this point in a minute, and it allows querying HDFS file and HBase. Okay, so if you have some data, you can move it to HDFS or HBase, and then you can start using Hive to query that data. Okay, it's as simple as that. Now, so that was the value proposition. Basically, you can create kind of a table over a CSV file, over a XML file, and then write an SQL query over that table. When this tick query runs, it gets converted into MapReduce, which will be churning the existing file lying on the file system. It's as simple as that. Okay, as we go forward, this is what will unfold. Okay, so it does not provide you record level update insert up to the previous versions. Okay, now in new versions it does. Okay, but still people won't use Hive for uh, record level modifications. Okay, so it never provided the record level modifications. Okay, it can generate new tables. It's not suitable for OLTP, because OLTP means online transaction processing. For online transaction processing you cannot use Hive. Okay, because every query gets done through MapReduce and has a higher latency. And Hadoop being batch oriented, it's not fast because there is always an overhead of MapReduce jobs. And it's great when the large data set is maintained as in the data is fairly static, and we want to mine them as in analyze them. All right, so here is a very simplistic diagram. Okay, there's just too many boxes, so don't get confused. So here you have Hive. Okay, so Hive basically converts SQL queries into MapReduce. Okay, although this is a diagram from Hadoop 1.0, but the process remains same. So there is this driver which does the main work, which takes SQL, it compiles the SQL, although we call that Hive QL. All right, it's a variant of SQL. So it takes the Hive QL, compile it, and then optimize and then executes it as a MapReduce task. Okay, so time to time it needs something called metastore. Metastore is basically, in very simplistic words, a form of data store. If you remember in Pig we created data sets, right? We said load data from this file into this data set where these should be the columns, right? In Pig, there was a problem. In case you exit Pig, that data set is lost. You will have to again type the same commands to create that data set, right? Because you have to again and again keep typing the same thing. So to avoid that, this that information that you created this particular data set is stored in Metastore in case of Hive. So in Hive also, before you start processing, you create a table, load data into table, and then you start writing your Hive query language, as in Hive QL, or you can say Hive SQL, whatever you prefer. So you write that query and that churns the actual files and information about actual files. It picks up from Metastore. Okay. So given a query, given a metastore, it prepares the MapReduce and then run it on Hadoop. So that's the main thing that goes here. And to call that driver, either you can call it from command line, from Hive web interface, and from thrift server, JDBC or ODBC. We will show you these two parts. And also from Ambari, Ambari has started allowing this, but we are yet to configure Ambari because hardly anybody uses Ambari's Hive. And you have karma then there are third sorry, this is Hive web interface. Okay, to get started the easiest thing is to use the CloudX lab. Just log in into the console, and once you log in into console, you can either run Hive from the command line, or if you have just single query, you can run it like this without so when you run without any argument, it starts the command, it's the console. Okay, let me just show you. So you open console. Okay, so it automatically moves the file from Hive to. So if you go into console, you can see that it is loaded. Okay, so here you can say, so similar to Pig, it also allows you to type the usual HDFS commands. Okay, such as DFS. Okay, and also let's just try to create a simple table and run a simple query. Okay, we can say we just created an empty table, it has nothing right now. Okay, and then we can say drop table X. Good. So we just created a simple table, did nothing, and deleted it. All right, so this was the normal console way where you can run this. The other way could be that you go into Hive and all right, so you go into Hive, write a query here, and say I'm saying select star from my stock data. You can see that. And this is basically a file. All right. So I'll come back to that again. So this is how you can run a simple query. Okay. Sometimes you just want to run a command, single query. You can run it from the console. And in case you have a file basically a script. A script means that all the command you have taken and put it in a single file that becomes your script. Okay. So a simple thing which I'm going to do right now, I'm going to copy the big.txt into big copy another file. Okay. Here Hadoop FSCP, which basically copies from HDFS to HDFS. All right. So here I go. Not here. I'll have to go to the console, exit here, say Hadoop CP this to big copy. All right, done. I've copied HDFS file from this read-only location to my home directory, and then I'm loading data. This is a Hello World program, by the way. I'm loading data from this big copy into docs. Okay, this will just create a table called docs, and then it will have only one column. Just a second. Did it work? Table not found. Okay, create table docs, and I could say line and varchar. Does it work? Oh, I have to use my own database. I could create a database called create database called SG, use database called SG. Okay. All right. So just okay. I'll describe everything what I'm doing right now. So first of all, we created a database. Okay. Coming back to it. So we created a database, and then using that database, and then after that we loaded this big copy into this table. Don't worry if you don't understand. The idea is that you may not understand completely, but you may understand it partially looking at these commands. So we are trying to load this copy of this big file into this table. Okay, as simple as that. And then we have say select star from docs limit 100. So this table which we have just created out of copying the out of this file called big copy. So this table called docs is nothing but uh, a table representing this file, kind of a view over table, view over this HDFS file. And when we are writing this query here, it says that nothing has been done so far. Never mind. So what am I going to do is I'm going to try to load it again. Okay, I'm going to load it again. Okay, it says that invalid path this, no file matching, not this way. I could say user Sandeep Giri 9034, and that's it. Okay, so I'm hoping that, alright, I'm hoping that it will work. Select star from docs. Alright, now it has created a file with a single column. You see that? Same file, the big txt is being represented as a table where there is only one column. Every full line is in that single column. Okay, now let's go ahead and try to basically first, this will basically break the line by space into words. Okay, and then do the group by and do this. Okay, so it's going to first break the line into one word and then group it by the word and then try to basically query that. Okay, so it's saying that it killed some vertices, input docs, no input path, specified job, get input path. Okay, something. All right. All right. Okay. Okay. Let me take a look at it again. Oh, I think I made a mistake here. Okay. Says select explode split line by space. That's correct. As word from docs. Okay, that's right. That's right. Okay, we'll look into it later. Looks like something is wrong in this query. Okay. Thank you, Ashok. So maybe I'll have to. So what he's saying, that he used line string instead of varchar 1000 and it worked for him. So maybe I can do the same thing. I could say drop table docs and create table docs, and I could say line string. All right. So we could say things like select star from docs, limit 100, and see if it works or not. Okay, we need to load data as well. Okay. Okay, let me keep putting here. And then let me put user slash Sandeep Giri 9034, and that's it. Okay, what did it say? Oh, the file is deleted. Yeah, so the file get deleted every time you delete the table. Okay, every time you drop the table, the underlying file will get deleted. Okay, all right. So I'm copying the file again. Okay, so this is the read-only file. I've copied it to my home directory. Okay, and then I've created a table called docs and loading this file which I've recently copied into docs. Okay, now I'm trying to check if select star from docs limit 100 means give me only 100 lines out of this table. Good, now it's working. All right. All right, now we can run it in our usual way. Why is what exactly is wrong with it? Anyway, I think if I run it from the console, it should work. Use SG, show tables. Good. Interesting. Interesting. So if I'm running this thing from the console, it seems to work. All right. Okay. So it'll run the MapReduce job and we'll do the word count. All right. Let's start with the rest of the discussion. This we have already talked. So you can run from the console, you can run dfs-ls command. From the console, you can call other queries and run them. And if you want to comment out certain line, you can put double dashes before the lines. You can set the environment variables using year equals to 0, 1, 2 kind of variables, and then use these environment variables in your Hive query. This is very useful because at number of times you have to call the same queries with different arguments. Say every day you have to call it with a different timestamp. So in that way, it's quite useful. Also, you can execute the shell commands without getting out of the Hive console. All right. Now the data types, the most important thing you need to know about data types in Hive, that for a same day, so first of all, most of these data types would look like a mishmash of all kinds of databases. So overall objective of Hive was to basically make all the people who are into SQL happy. Okay, so that they can happily start using Hadoop for their work. Okay, for them it becomes like a zero effort. Whatever their queries are, if they can run on Hive, so they can simply move the data to HDFS and then load the table and start using the same queries which they have been using on Oracle, MySQL, or MS SQL. So Hive has made sure that all the data types are available from all kinds of databases. Okay, so you can see string, you can see timestamp. For string you have varchar, char, and similarly for bitwise you have boolean and binary. Integer you have tiny int, small int, big int, float, double, decimal, and so on. So you will find the various kinds of data types for the same thing in Hive. Alright, and as and when the version of Hive is progressing, more and more data types are being supported. Say, for example, the complex data types are supported such that people coming from Postgres can use it happily. So the complex data types are modeled after Postgres mostly. So you have arrays, you have maps. Arrays is a basically array of integer and or other complex data type. Maps are basically maps of primitive data type versus any other data type. This the value could be complex, but the key has to be either string, integer, or something. All right. In struct, it's always column name and data type, and optionally you could put comment. And sometimes you have like union. The union data type is interesting. If you have multiple kinds of values that would come in the same column. For example, let us take a case of your website. You are allowing the users to use various kind of authentication. Say some users come with their Google ID, some user come from Facebook, some user come from LinkedIn. So they can use any of the connectors, say sign in with Google, sign in with Facebook, sign in with LinkedIn, or actually sign up with the email address. Okay, so the ID, the so if you think about it, in your website the authentication ID would be only one if the user has come either from Google or LinkedIn or Facebook. And the data type might get different. Let's say Facebook is giving you a big number to uniquely identify the user instead of giving you the email ID, while Gmail is giving you the Google ID and LinkedIn is also giving you the LinkedIn ID. So sometimes some users will have their user ID denoted by integer. Some users will have the authentication ID denoted by email ID, and some users might have something else. But users may not have multiple authentication ID, right? So in such scenario, you create a union kind of a data type for the column. All right. So databases is nothing new. You must have used everywhere. It's like a folder to separate my data from yours. Okay. To see what all databases are there, you could say show databases, and it will show you all the databases. You can try right away from the console or from the web and see all list of the databases. From the web, you can also see the list of databases here. And here you can always see what's wrong with this. Okay, looks like it is running. All right. So you can have the databases, and you can create your own database. And generally, before starting to work, you should create your own database and use that particular database. Okay. You could also drop the database if you want. And sometimes while creating database, you can also use if exist and similar to drop database. All right. Okay, so it has finally succeeded. Okay, so one of them is running. Okay, it has succeeded finally. And yeah, it has given us the, you can see the word count here. It has given us the word count and so on. All right. All right, so good. All right, so now the main work. So similar to SQL tables, the only, I think the only idea you need to understand is the idea of a table, and rest is standard SQL. Okay, so similar to SQL, there's not much of a difference. So you could always say show tables to get the list of table, and to get query your table, you could say select star from your table, and then you could also say describe your table. It will show you the details about your table. Okay, so you could say describe docs. You don't need to put quotes. Okay, it says that there is only one column in the. Similarly, we could say describe word counts. You can see there are two columns, one is word, another is count. All right. Now we have, so we can see that in detail exactly what's there inside my table, saying describe formatted and then the table name. You can see it shows clearly that what all is there inside docs. There is a column called line which has got data type called string, and database name is SG, and the owner is this guy, and last access time is not known. Interesting. And then you have create time is given, location is given. This is something interesting. Okay, so you can see that every date, every file is being stored inside this warehouse folder. Okay, inside warehouse folder it creates one folder for databases, and then one folder called docs. Okay, if you want to check what's there inside it, you could actually do it quickly. Okay, so I'm saying control Z. Control Z means send it to the background. I sent a process to the background and I'm running the, you can see in HDFS there was this folder created called docs for my table, and my file called big copy has been moved there. Okay, so that's what happens when we load a data. All right, so there are basically two kinds of table. One is called managed tables and external tables. The only difference between managed tables is that when you drop the table, the underlying data gets deleted. In external table, if you delete the data, if you delete a table, it does not delete the data. There is no other difference between managed table and external tables. Okay, so life cycle of the table is managed by somebody else in case of external. In case of yours, okay, so basically do not delete the table if it is managed. If you do not specify explicitly that you are creating an external table, okay, that means you're creating a managed table, and if you drop the table, underlying data will get deleted. I'll show you this. So here right now when I'm saying, when we said Hadoop FS this, and if I say drop table docs, okay, now if I go back to console and the check in HDFS Hadoop fs minus ls, the docs is no longer found. So the whole HDFS folder containing that file gets deleted when you did drop a table, because it was a managed table. Okay, so that's the only difference between the two. Rest of the process is same. Okay, so what is Hive Metastore? It stores the metadata of tables. Okay, you can just check if you want. You can just, if you are really curious, you can go to MySQL. Can I connect to? Is MySQL is somewhere else? I'll give you the login password later. Okay, so basically there is a MySQL database running in which Hive is storing the name of all the tables. All right. Now let's look at the manage table. So we are creating a table called NYSE, exchange one, symbol one, and all the jazz here. Okay, and it's basically loading NYSE database. Okay, so I think we can do a better job. Okay. Okay, I'll not put the location right now. I'll just create. So location means where to create this table. Okay, where to create this table. Right now, I'm just saying create it in a default location. Create table NYSE with this information. All right. So I'm keeping it more like a hands-on so that we all are able to create. But before creating your tables, please create your own database using create database mechanism. Okay. It says that already exists. Okay, let me just use SG, my own database, the one which I created. And okay, so I've created this empty table right now. It doesn't have anything. Okay, so essentially now I'm going to load data into this table. So I'm saying load data into in this path into this. Okay, right now I'm going to use a keyword called local. Local means from my local machine. Okay, it says that the table not found. What was the table? NYSE. It says there is no local file available. So what I can do is I can copy Hadoop fs minus ls slash data. Okay, there is all right. So here NYSE good and NYSE daily. I'll just copy this file to my local directory and then I will run the command again. Okay, so this folder, okay, yeah, let me just copy this one. Hadoop fs minus copy to local and this one. So I've copied this file to my local directory and going back to Hive, fg is a command which brings any running process into the foreground, and if I want to send it to stop a running process, I can always press Ctrl Z and then again fg. Okay, but you can always open two terminals and do the things parallel. Okay, rather than juggling between these two things. Okay, so now what you can do is you can basically, yeah, so here we are going to say what was the name of the file, NYSE daily underscore file. That's the name of my file. All right, NYSE. Okay, so I'm saying load data local. In this file, overwrite into NYSE this table. Okay, this is what I'm going to do. Looks like I'll have to again start Hive. Use SG. All right. Okay, do you think anything wrong with it? Oh, I'm not saying load there. While copy pasting, it has done something wrong. Okay, so let's try to load the data from my local file. So it says no matching file found. Why is it so? Oh, it's in caps. No, we have in caps. Okay, okay. So this is the file we had copied earlier. this one. Let's try to do it. NYSE daily file. NYSE daily file. Okay, so I could also say home slash Sandeep Giri 9034 slash. Okay, let me try again. I hope this time it would work. Alright, looks like it has worked this time by using an absolute location limit 100. Good. So we are able to load data from the file into this. Okay. All right. I'm going to go back a step. So what we did just now is created this table, empty table. Okay. Also mentioned here that my data is formatted such that the columns are separated by /t. Okay. By default, it looks for control A character. But if you mention that my rows format is such that the fields are delimited by /t, so the file which we are loading into the table should contain the columns such that the one column from another is separated by /t. /t is tab. Okay, that's what we did just now. All right. So we basically first made a local copy of our this file and loaded it. Okay. We could have also simply loaded it from HDFS. If we do not use the local keyword, we can directly load the data from HDFS into a table, okay, such that load data in path. So by default, the load command loads the data separated by control A unless you specify some other character in the table description. And for every when we are loading data into the table, when we create table, it only creates entry in the meta store. And when we load data into a table, it creates directory, it copies the data which you give it to it, and then basically in the when we query it, it talks to the HDFS and gives back the data. Okay, so only the metadata like column name, database name is stored in metastore. Rest is in HDFS. All right. Now we can query NYSE and say things like symbol equals to CMC. Okay. So we could say select star from NYSE and where symbol equals to CMC. All right. So what is wrong with it? I think then yeah, there is a column called symbol one. Now you can see that we have been so fluently able to query our data. So we can start doing other kind of magic. Say, let's say describe NYSE. So it has got, say, second one is symbol, then date, then price open. Okay, so we can say select star from NYSE where price open is greater than 15. Oh, there are, yeah, so there's some. So you can basically easily query your data which is lying in HDFS. Okay, All right. So again, so here basically the first I tried to load the data from the local directory. In the similar way, you could load the data from HDFS. First, you make a copy from the read-only place. Okay. Then you check whether the file has been copied to your home directory or to the directory where you want it to copy, and then you load the data from that location into the table in the following way. So instead of saying local, you simply say load data in this path, overwrite into the table. And once that is done, you check whether the file is there or not. File would disappear. Okay, the file where the actual data was. So basically the important thing you should remember is whenever you load data from HDFS, it actually moves data from this source location to the location of the table. All right, so that is something very important to know. So by default, the data is located in apps Hive warehouse as I showed you, and then otherwise you can mention in the location in the table description. While creating the table, you could say location is this. Okay. If you want to save the data into your local file system from the Hive interactive command, you could say insert a override local directory. Okay, and then whatever is your query, you can execute that query and it will store here. Okay, similarly you could, if you omit local word from here, it will try to create a directory in HDFS. Now every Hive table comes with something called partitions. To avoid the full file scan instead of partial scan, we use partitions. Okay, so the data is stored in different files based on various combinations of the columns. So as we saw earlier that for a table it creates a folder. For each partition of the table, it will create further folders in the table. Okay, I'll show you that. So you have just that you have to define the partition using partition by in the create table. So while creating a table, you could load data from multiple locations, and that's what is a partition. So partition A loaded from some other file, partition B loaded from some other file. Okay, so partition can happen on multiple columns. So what do we mean by that? I think the next slide will describe it better. Okay, let's take an example and you will understand that. All right, so okay, now the important part to understand is when we load data, it moves the data from HDFS. Why? Because the data in HDFS is anyway taking too much of space. Okay, therefore it's better to move data in HDFS rather than copying from here to there, because most of the data when talk about HDFS, this data is like few GBs or more than GBs. Therefore it's a valid assumption to move data in HDFS, just like in your, if you are dragging and dropping a file from C colon to D colon, from C to D, the data will get copied. If you drag the folder from C colon to another folder in C colon, then it will get moved. Okay, the way the assumption in Windows is there, similarly a similar assumption has been made by Hive developers. Okay, so let's talk about partitions. Imagine that you have a table called the amp. Okay, it has got three columns: Sandeep 10, BTech, Shravani 9, MA, something, some values. Okay, now if you have another table called the amp1 which is having other values for some other fields. Okay, so you create one more column called qualification. For qualification equal to 1, you could load the data from the amp. Okay, and for qualification equals to 2, you could load the data from another file. So you are creating an artificial column called qualification, and that you can mention in the create table itself. Create table employees, and then you partition by a field, and then you limit the rows by a certain character. And then here the important part is to understand that there is one extra column called qualification, which is not there in the data which we are loading. Okay, so while loading the data from the amp, we will say that the value in qualification column is 1, Similarly, while loading from other file, say the amp1, we are saying that qualification equals to 2. Okay, so basically under employees table there will be two files, the amp and the amp1, and in metastore we will flag that for qualification equals to 1 there is one file, qualification equals to 2 there is another file. You can see here that once we load data in employees, inside employees, for every value, say qualification equal to 1, there will be one folder, and qualification equal to 2 will be another folder. You can see that. And under qualification 1 will be this file called the amp, and qualification equal to 2 there will be another file called the amp1. Okay, it's like in the databases everything is a column, while in file system it's a folder. Okay, you remember those days when you used to manage your singers inside folders, and so on. And in the database like iTunes or something else, everything is a column. Similarly, here what Hive is trying to do is to represent folder structure using column approach, and that's what is partitioning about. Okay, so we keep on creating multiple kind of columns for each different permutation of the values. All right, now the usual data definition language, data definition as in you could create a table, alter the column, add more columns, and so on. That all of the DDL is available as such. For example, if you want to rename a table, let's say alter this particular table, rename to this. Okay, you can rename a table, and you can change the columns and put more comment, and similarly you can add more columns saying alter table, add these columns. You could also delete a particular partition. Okay, and so on. All right, now the external table. Okay, there's only minor difference between external table, that when you drop this table it won't drop the underlying data, so there is not much to do here. Alright, so sometimes you may want to query a third-party remotely located table such as S3. You could create an external table on top of a remotely located table. The external table will not copy data from remotely located table, but when you query it, then it will bring data from there. So querying an external table could be very expensive. Okay, so sometimes your table could be external and partitioned. Okay, meaning one partition is coming from one S3, other partition is coming from HDFS. What is S3? S3 is a Amazon storage. Amazon provides a very cheap and very robust data store mechanism, and that's S3. That's called S3. Okay, all the logs we generally push to the S3 only. Sometimes you can have external partition like this, meaning one partition is coming from HDFS, other is coming from S3. Okay, so you have created a table earlier without the location, and you have just mentioned that this table will be having three more columns, on the basis of which partitions will be generated, and then you can add the partitions there, and so on. All right, so we have a few notes. So again, let me reiterate whatever we have discussed. Each table has got a location. By default, that location is apps Hive warehouse. You can override that location by mentioning location in the create table clause. When you load the data into the table, it copies the data if the data is local as in on the local computer. Otherwise, if the data is in HDFS, load will move the data from one folder to another. Dropping a managed table drops and deletes the data under the basically at the location of the table, and dropping an external table does not delete the data at the location. The meta store is maintained on a relational table, and that's called Hive meta store. Okay, so it provides you a great select statement, usual SQL queries. So you can have, say, call a function. If you have a column which is basically a map, you can query the map as well, because as we talked earlier, the data type could be a map, or you could call, you could do a kind of a mathematical operations as well, and you can combine, say, function call, mathematical operations, and the complex data types. And you can use the aggregations. Now the only thing you have to know about aggregation is that Hadoop provides you to optimize some of the aggregations. Say for example, count star actually can be done on the map side itself without any reduce phase. So lot of map side operations could be improved by turning on the Hive map aggregation equals to true. Okay. Now, views. Whenever we are creating a temporary table, it persists the data, meaning even if the source changes, the temporary table will have the old data. And that's where views come into the play. Okay. So if there is a complex, or you can say, when you have complex queries, you can create views over it so that you can simplify the complex queries by breaking them down into views, right? If you saw our previous example where we were doing word count, you could comfortably create a view out of the subqueries and then join them. Okay, to simplify bigger queries, you could convert them into a bunch of views so that you can use them. Okay, so you can simply say create view and give the whole select query. Next is that sometimes you want to create custom functions. In the same way, the way we did for pig, you could also do the same for Hive as well. So all you have to do is you could create a custom class, and the way we created for Hive, you could also create for the way we created for pig, you could also create one UDF for Hive. And then once you have created this, you add that, you compile that, export it, and then copy it to the server. And then you could simply say add jar. The good part about Hive is that it can pick up the jar from HDFS. Okay, so you could simply say add jar and this. Okay, you could have a look at the example. Yeah, you could have a look at the Hive example UDF project. So you could basically download this example project, and just the way we did for pig, you could do the same thing here. Export jar, and then once you have added this jar into your project, you could define a temporary function, and then you could call that function and start using it. Okay, let me explain again. So sometimes it's difficult to create a logic using HiveQL. In those cases, when you see that, okay, this is a string manipulation, or this is something which is character by character manipulation, or something very low level, in those cases, you would like to code that part in Java. So you would like to create a UDF. So you can have a look at the sample project by importing this project, by importing this, downloading it and zipping, and then importing it into your Eclipse, and then start using it. Okay, just the way we did for Pig. All right. Sometimes you have to load JSON data. Till now, we have been only loading tab separated data. Sometimes you may want to load JSON data. You can simply use JSON Survey. Okay, you can use JSON Survey and download this and start using that binary. Okay, how would you use that? You'll say add jar and you will specify its location. Okay, if you have put it in the HDFS, you could say, you could give its location. All right, and you could create a table like this. So first, If you want to parse JSON data, first your data has to be available in HDFS. Second, you download this library, JSON library. We call them Surday. Surday means serializer, deserializer. Basically, these libraries convert the raw data or JSON data into tabular format for loading. When Hive calls load, this library converts JSON data into tabular form. And then when Hive says store, these libraries help us translate the tabular format data into JSON data. So this library contains the kind of a UDF. Okay, so you can say after downloading these libraries, the actual project is here and the binaries are here, and you can simply download it and say add jar. And once that is done, you can create a table, and here you could say, instead of saying raw format was delimited by tab, you could say sorry, not raw, row format. Instead of being tab delimited, here we are saying my row is a JSON format, is supposed to be handled by my survey called JSON survey. So for every line, this my input data is being fed to JSON, and JSON is survey is converting that into our record. Okay, and once that is done, we'll be able to churn JSON data using Hive. Okay, also please note that it's not ETL. In ETL, you translate data and store. You could do ETL from here actually, but here we are not saving the translated data. We are just loading it in the due course of MapReduce. Okay, if we could have said save this table tweets somewhere on the disk, that's translation from JSON to tabular format. Next is sorting and distributing. This is something we need to know, that ordering is great as long as we have single reducer. The moment we have multiple reducer, the problem of ordering becomes bigger and bigger. For example, in case of MapReduce, when we did word count, there was one single file. Words were in order from top to bottom. But the moment we had multiple reducers, we had two separate files. In each file, the data was sorted. But if you just concatenate these two files, the output may not be sorted, right? And to have such that the ranges of first file and second file, which were output of our MapReduce. So if our MapReduce is having two files, two output files, right? As a result of that, we mentioned in our config that we want two reducers. So if you want two reducers, there will be two output files, and these ranges say one file is also containing apple, the other file is containing apricot, the first file is containing ball, other file is containing boy, and so on. So the ranges of data, first file will also go from A to Z, and second file will also go from A to Z. Now, even though individual file was well sorted, but when you concatenate the two file, it's not sorted. The output is not sorted. Okay. Therefore, there is a little problem when it comes to sorting in the distributed environment. Okay. All I'm trying to say is part one of my MapReduce could look like apricot and apricot, boy and Jew, and part two might look like apple, boat, and zebra, right? While we are doing MapReduce, unless we are using partitioner in MapReduce. Okay, so again, if we have number of reducers as 2, there will be two partitions, part 0 and part 1. Okay, part 0 generally you can say part 0 here, and part 1. So when we are sorting, right, so the data is not really sorted. If we concatenate the two, the order will be apricot boy Jew and apple board zebra, right? Therefore we need to use partitioning, and the same problem arises with Hive as well. So initially there was order by, it guaranteed global ordering, but it will push all of the data through single reducer. This was basically unacceptable for large data set. Again, the reasoning is order by X should not be used when the data is huge, because it will have only one reducer underneath, and therefore it will become impossible for single reducer. So they came up with the idea of distributing. So basically you could use sort by X, which basically says have multiple reducer, but then individual bucket will not be separate, right? Because one will, it will cause the multiple reducer. So if you have sort by X, it will basically create multiple reducers, okay, but it will not, the resultant will not be sorted. So that's where the idea of distribute by X came into play. Now if you combine the idea of distribute by have the partitioning, and sort by means have the multiple reducers. Okay, so basically if you combine a partitioner with order by, then the resulting is the good sorting using multiple reducers. Basically, distribute by X make sure that the range is not overlapping. So if you enable distribute by, so part 1 will contain apricot and apple, boy, boat, and part 2 will contain zebra and Jew. Okay, let me just fix it. Yeah, part 1 will contain something of this way. So that's a difference. So distribute by essentially is saying we are going to use MapReduce partitioner, and sort by says ki, okay, we'll have multiple reducers while sorting. If you combine the two, the resulting is the correct way of order by, and that's what is done by cluster by. Okay, cluster by. So cluster by is essentially a more scalable version of order by. So you could say select column 1, column 2 from T1, distribute by column 1, sort by this. Okay, or you could simply say cluster by column 1. Alright, so that was sorting, and there is an idea of called bucketing. Bucketing means we could break a particular column into buckets. Okay, we could break a particular column into buckets. So uh, so basically while we are clustering here, meaning sorting the data properly, we could specify how many buckets do we want to create, meaning how many reducers do we want to create. All right, now let's take a look at the quick demo. Okay, so first of all we will download data. I think I'll just change this particular step for you. Okay, I think this is better to have order like this. Okay, and I'll remove this exclamation because it means run this command locally, not inside this. Okay, I will say here start Hive using, okay, here is the say second step, first step and then 0th step. Alright, so what are we going to do using Hive? It's a good example. Okay, you might want to make note of it. Alright, so first step is let's get some data. I have already downloaded this data and it's available for me. Okay, alright, let me just open my console here, and here is my data. Okay, let me take out in a separate tab so that I don't have to worry about. Okay, so you have ML this. Okay, it's a 4.7 MB data. Okay, I've already downloaded this. wget basically downloads the anything, any URL, and for those who are curious and would like to understand more, must actually go through wget. Wget is a very powerful command. You want to download the entire website, you can use wget. Okay, so download data, and once we have downloaded data, we can unzip it. Unzip ml. Good, it's unzipped. Now you can see that there's a folder created called ml. Now let's start Hive and create this table. Okay, let's start Hive. Okay, let me increase the font. Okay, so I've started Hive, and now I'm about to say create use SG, meaning I'm shifting to my own database, and then I'm creating a table called udata. Right now this table has nothing. Okay, next thing I'm going to do is I'm going to load this particular file into this table. Okay, I'm going to load this particular file into this table. You can see I've said load data local. In this path, I've given the relative location from my current directory. Current directory is where I've extracted this particular file, and then I've said override into udata. Now you can see select star from udata, limit 100. Okay, so those who are curious what is there in this file is basically the movie ratings. It's basically the movie data. It has got user ID, movie ID, ratings, and Unix timestamp. Okay, so in one of the examples when we talk about Mahat, we'll be using the same data again, but bigger data set. Right now it's 100,000 ratings of movies by different people. Okay, so here it says user ID, movie ID, and ratings given by user ID 11 to 111 as at this particular times. Okay, the time is represented as a big number, as in big milliseconds, since 1st January 1970. Okay, so basically it's very trivial data. Okay, now once we have loaded this, we can start churning, doing various kinds of churning very quickly. Okay, so for example, I'm going to say for each user how many movies he has rated. I want to find out. Okay, again let me show you. So what does this have? It has user ID, movie ID, and ratings. Okay, so for each movie, I want to, if I have to compute average rating, what will I do? Question is, what is average rating for each movie? That's the question. So it says select movie ID, average of ratings from table, from what was the table name? U underscore data group by movie ID. Okay, let's see how many errors do we get. It says that expression not in group. Okay, which means, all right, let me correct this. All right, so here I think it is correct. Okay, says, yeah, you can see in the job browser that my query has been accepted. 5% maps are done, 5% reduces are done. Nice. 100% maps are done, and so on. Now, this is batch, by the way. That okay? Because this query could have run really, really smoothly. Okay. Now, if the query goes complex, right, it'll be difficult for you to actually do the same thing, right? So what I would suggest you to do is use the views along with these complex queries to basically solve these two problems. Okay, so you have to first find out for each movies how many users have voted for it. Okay, how each for each movies how many people have voted it. Now the movies which have been voted by more than 30 people, what is the average rating? For these two problems are the assignment for Hive. All right. Okay, recap of Hive again. So it's suitable for data warehouses where relatively static data is maintained and analyzed, and we do not require very fast response, as you just saw that it takes some amount of time. The same thing if you do it in a regular database, it would be really, really fast. But the great thing about Hive is that it can churn terabytes or petabytes of data on your Hadoop cluster without any problems. Okay, which is something you can't dream with the regular database. Okay, because the disk reads becomes really, really painful in the usual case scenarios. Okay, so that was pretty much about Hive.